where all of the d orbitals, they experience a repulsion which is equivalent, and all of them, their energy increases. And that energy level, the average energy of the d orbitals in the spherical field, spherically symmetrical field, that is known as the barycenter. And further, then when the metal is approached by ligands properly, then we see that the ligands are approaching to the axis, because that is the most symmetrical way when you are having an octahedral complex. Octahedral complex, or when you are having six ligands, that the ligands are going to approach from the axis, because we have three axes, x, y, and z. If I take the negatives, I will get the six positive and negatives together. So from those axes, the ligands are going to approach. Now, in that axis, ligands are going to also interact with, they are going to feel repulsion with the d orbitals, which are axial d orbitals, namely dx square minus y square and dz square. And what will happen? Their energy is going to further increase. The orbitals who have the lobes on the axis, their energy is going to increase, and that two orbitals are known as the EG set of orbitals. And how much higher is the energy? It is 3 by 5 times whatever was there in the barycenter. And the rest of the d orbitals, namely the non-axial d orbitals, dxy, yz, and dxz, they are going to experience lesser repulsion, and that is why their energy is going to decrease. And how much is this going to decrease? 2 by 5 del O. And those three orbitals are known as the T2G set of orbitals. So this complete thing happens in the octahedral splitting. Next, we are going to look at the tetrahedral splitting. Fine, we are going to look at the tetrahedral splitting. So first of all, I will write about tetrahedral splitting. We have seen the A part, that is octahedral splitting. B part is the tetrahedral. Just give me a second, please. We have tetrahedral splitting. So in tetrahedral splitting, what happens? Should I show you guys? Chalo, let me show you. I'm taking a leap of faith that you are going to understand this, but still let us see. So let us suppose we have a cube which is going to represent the yes, I think that's going to be fine. You don't need to make this. I'm just. Can I make a cuboid? No. So this is the metal. ठीक है और जब आपके पास when you are going to have ligands that are six ligands ना, then those six ligands they approach from the faces. There are six faces, one down, one up, one on the back side that I have written in the dotted structure, and then in the front we are going to write it in a bold. So there, these are the six ligands of the octahedral splitting. They approach from the face center. Right? If you are assuming the metal to be at the body center of a particular cube, then the ligands are going to approach from the face center. What happens in the axial cases? what happens in the tetrahedral case? So these are the axes. In the same way we are having all the other orbitals. These are the axes. The octahedral, it is going to approach from the alternate corners. This corner, not this corner, this corner. Now, not this corner because it's not going to be alternate. This corner, and again, we cannot take this corner because this will not be alternate. We cannot take this corner. We are going to take this corner. Okay. So from here the ligands are going to approach. Now, if I make the non-axial ones, the non-axial ones are going to be like this. One is going to point in this direction, this direction. One is going to point on this direction here, right? And the others are going to point on this direction and this direction. So that is why what happens. The ligands which are approaching, like the non-axial ligands, they are not coming directly in the pathway of the ligand. Okay, the non-axial d orbitals, they are not coming in the pathway of the ligands. Okay, as the axial ones were coming in the case of octahedral splitting. Right. So that is why the splitting in this case what happens. So by the way, थोड़ा सा और बता देते हैं. इसका अगर देखिए आप, देखते हैं. Now I hope you can understand that even though this red dotted line, it is it's like approaching the. Okay. I hope now it is more clear. Now let us show the ligands. Let me move this front. Bring to front. This is the metal. Now please see. This one is your, let us suppose, x-axis. This one is your y-axis, and this one is your z-axis. If I will make the ligand like this, the non-axial ones, we can see that this is the non-axial orbitals, and this is, let us suppose, the axial ones. Fine. You can see that if the ligands are going to approach in this direction, fine, then the ligands are quite far away from the axial one, but they are kind of a bit closer to the non-axial one. They're not approaching directly to the non-axial one for sure, but they are rather closer to the non-axial one if I compare it with the axial one. Okay, because you can see they are coming from what? They're coming from the corners, right? And corner is going to be obviously what? It is going to be corner. और भी हम थोड़ा सा और एक्सपेक्ट करते हैं अभी. These are approaching from corners, and if I extend this particular lobe, this lobe is going to go to the edge center. If I extend the axial one is going to go to the face center. Now this is the face center and this is the edge center. If I talk about the cube and the edge length is A, then the ligand is how much far away from the lobe? It is A by 2 in the case of what? For the case of axial, non-axial ones. The axial ligands are at the face center. Now, what is the distance of the face center here? This is A. This is going to be also A. So this whole thing will be, according to the Pythagoras theorem, it is going to be root 2a, or rather I should say a root 2, a root 2, according to Pythagoras theorem, because this is a, this is a. The hypotenuse is going to be a root 2, and this is the half of hypotenuse. That's why it is going to be, what this distance is going to be, a root 2 upon 2, or I can say that this is going to be equal to how much, a by root 2. So obviously this 2 is larger, root 2 is smaller than 2. So I can say that if the denominator is high, this distance, what this distance will be, I can say that a by 2 is smaller than a by root 2. So by that factor, we can say that axial ones are far away. This is where the axial ones are present, and this is where the non-axial ones are present. So non-axial one is closer to the ligand, and that is why the non-axial d orbitals will have an increase in energy. The axial ones are going to have a decrease in energy overall. क्या पढ़ा दिया हमने, सुना था आप लोग क्या लिखा, तो हम बोल देते. Write the B part, that is tetrahedral splitting. इसमें लिखिए 4 ligands approach the central metal atom, between the axes. I mean, not very strictly between the axes, but they are obviously in between the axes only. I mean, we cannot say anything else. They're not strictly between the axes, so that they are going to find the non-axial loop, but they are in between that. They are not on the axis. Okay, this leads to, consequence is more important. Like the cause is not very important for you guys. This leads to, what is happening here? Leads to increase in energy of non-axial d orbitals. Which one? Dxy, dyz, and dxz. And this set is known as T2 orbitals. Next is the axial d orbitals. Experience decrease in energy. Experience decrease in energy. And what are these orbitals? Dx square minus y square. And the second one is dz square. This is known as the E orbitals. Write a note. The subscript G in P2G and EG stands for gyrate, showing that octahedral or octahedral geometry has center of symmetry. Now, if I have something like this, for example, B, 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 and B. So if I am at the center, if I go upwards, I will find B. And in the same way, if I go to the opposite direction, I will find B. If I am in the center and I go rightwards, I will not find anything. And the same distance, if I travel in the leftward direction also, I will not find anything. But if I go like this, I will find something. And if I go in the same direction backwards, I will find the same B. So that is known as the center of symmetry, which is observed in octahedral. Has center of symmetry, but as tetrahedral geometry, doesn't have COS, center of symmetry. We don't use the subscript, subscript, subscript is G. ठीक है, तो G word का the G letter is not used in the case of tetrahedral. Why? Because they don't have any center of symmetry. है ना? If you have seen this and this is like this. A, this is in front, this is in back. So if you go upwards, so you are in the same plane. If you go downwards in the same plane, you will not find anything because uh, this dash thing, na, this thing, this is coming forward. Na, it is coming out of the screen. These single lines are what on the screen. So I am now going downwards on the screen. I will not find anything. I will not find B in the downward direction. Why? Because we have this wedge which is coming out of the screen. It is not downwards. Similarly, इसमें देखिए आप ना यहाँ पे this is like this, and here you don't have any B. So this does not have any center of symmetry. Copy this down. Raise your hand once you're done.
Sir, in octahedral, is every bond on the same plane then?
No, 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 no. Not on the same plane. Actual structure तो इसका ऐसा होता है. These two are in the same plane. B and B. This is going backwards. This is coming forward. This is coming forward, and this is going backwards. So, but the consequence is the same, ना? If D के लिए अगर आप कैसे जा रहे हैं? You are going rightwards and inside. Rightwards inside. इसके लिए leftward outside. You are going to get the B. Make sense?
Yes, sir.
ये सारी चीजें ना आपसे वाइवा में पूछी जाएंगी, तो जब आप लोग when you will be doing the practicals ना at that time it will be asked. Let me know once you're done. Okay, is everyone done? No. Oh my God. Soha. Assalamu alaikum, Soha. How are you? Soha, am I audible? Hello. Khadija, Mariam and Soha waiting for you guys. बताइए इतने इतने दिन बाद आ रहे हैं बच्चे. Soha, am I audible? Waiting for Khadija and Soha. Please write quickly. Waiting for Khadija and Soha. Those who are not done, please let me know. Let me know if you are not done. चलिए. हाँ, एक नोट में आपने ये पॉइंट लिखा, अगला नोट में लिखेगा. Since एक काम करते इसको छोड़ दीजिए, पहले आप लोग जरा ड्राइंग बना लीजिए इसका. दिस वाज फ्रॉम ऑक्टाहेड्रल, इसी को थोड़ा सा हम चेंज कर देंगे. So basically, this part is going to get tilted. घबराइए मत आप लोग. D ऑर्बिटल्स इन नॉट ऑक्टाहेड्रल फील्ड, इसको भी चेंज करो. This thing is also going to change. Now, this is obviously the very center still. This is the very center. Now, this whole thing will be known as del T, because this is the difference in the energy of, this is known as the E orbitals, no, T2 orbitals. This will be the T2 orbital. This will be the E orbital. And the T2 orbitals are going to be obviously dxy, dyz, and dxz. And the E orbitals are going to be obviously, let me make it first, ना उसके बाद से चालू कीजिए. Dx square minus y square, and it's going to be dz square. Both of these are going to give you the E and D orbitals in the tetrahedral field. Now, the T2 orbitals are going to be above the very center. How much above? 2 by 5 del T. 2 by 5 del T. And E orbitals are going to be below how much? 3 by 5 del T. D orbitals in free state, average energy of the D orbitals in spherical field. D orbitals in tetrahedral field, very center. Yeah, everything is fine. Yeah, please copy this down. Raise your hand once you're done. Raise your hand once you're done. Soha, I am just waiting for you, Soha. आपको मेरी आवाज भी आ रही है कि नहीं आ रही? लाइव भी नहीं कर रही है। चलिए, नेक्स्ट इसके बाद नोट लिखिएगा। Since del T is given by only four ligands and del O is given by six ligands, therefore del T is smaller than del O. Del O क्या होता है? बड़ा होता है. What is the relation? It's very important. Del T, it is equal to 4 by 9 times of del. ठीक है, obviously del T is going to be smaller. This is going to be very important relationship. इसको please याद रखिएगा. Waiting for Soha and Yahya. चलिए, सोहा तो पता नहीं आप हैं नहीं है, बोल ही नहीं रही हैं, क्या? देखिए, अगला जो है प्रिडिक्शन ऑफ पेयरिंग और नॉट पेयरिंग, है ना? whether the pairing of electrons will take place or the pairing of electrons will not take place, that we are going to understand. तो यहाँ पे लिखिएगा prediction of pairing of electrons. इसका कंसेप्ट बहुत सिंपल है, ध्यान दीजिए. नो मैटर वेदर इट इज डेल P और डेल O, ऑक्टाइडल फील्ड है या फिर टेट्राइडल फील्ड है, if the del is greater, देखिए फॉर एग्जांपल आई एम टेकिंग del O, ठीक है? So here we are going to have Eg, there are two orbital in the Eg and T2G में आपके पास तीन होंगे, and I'm going to take the case of D4. Fine. So D4 में क्या हो सकता है? Either electron will go like this 1 2 3, obviously it is going to go to the lower energy state possible, right? Now the fourth electron has two choices. एक choice तो ये है कि या तो ये यहाँ चला जाए, दूसरा choice क्या है? 1 2 3 4, तो pairing हो जाए. Now in both the cases the electron has to experience some increase in energy. यहाँ पे जो increase होगी, this will be equal to, in the first case whatever there is an increase, it will be equal to del O, और यहाँ पे भी also it is going to have an increase in energy, and that increase will be because of the pairing energy, we call it, because of the electronic repulsion, because of the electronic repulsion. That means there are two bad things. Out of the two bad, electron choose whatever is lesser, है ना? जैसे दो, अगर आपके पास खराब काम है तो आप कौन सी चूज करेंगे? whatever is lesser. So here both the things are bad for it, na? If it is going to go to the higher energy level, that is the Eg level, then also it is going to increase in energy. What will be the increase in energy? Del O increase हो जाएगा. But if it wants to pair, then there will be repulsion, and because of that, how much energy will be increased? Pairing energy. So what will be the electron doing? Electron will do whatever is lesser. If it is going to the del O part, if it is choosing del O, that means obviously pairing energy was greater than del O. ठीक है, del O छोटा था, right? That is why it said that okay, fine, I will not get paired, because if I am going to get paired, then I will be having repulsion, which will increase the energy more than that of del O, then he has to choose the lesser evil, that is del O. But if the electron is doing pairing, then what does it say? It says that the pairing was smaller than del O. Pairing was smaller than del O. This del O was very high. This del O was very large. Now, if you think about it, the pairing energy will be constant, whether it is an electron of cobalt, nickel, iron. Electron is electron. All the electrons are going to have the same charge. It is not going to depend on anything. The pairing energy is going to be constant. What's going to change with respect to a particular central metal atom, with respect to its oxidation state, with respect to its ligand, is the del O or del T, if you are taking the tetrahedral splitting. So, first thing is that if del O or T जो भी है, it is del O या del T, whatever it is greater than pairing, it is larger than pairing, then pairing takes place. जो छोटा होगा lesser of the evil है ना, ये याद रखिएगा. Both of these things are bad, both of these are evils, but we have to choose a lesser evil. Then pairing takes place. Pairing takes place. But if del O or del T, it is smaller than the pairing energy, then pairing doesn't happen, doesn't occur. Okay, now we have to see what are the factors that affect the magnitude of del O and del T. Copy this down, raise your hand once you're done. All of you understood this simple concept? Mariam, Khadija, Anna, Siddiqa, Harsha, and Nikia.
Yes,
समझ में
sir.
आया सबको? Yes, ठीक है. Just waiting for you here. देखिए, the magnitude of the crystal field splitting energy है ना, del तो क्या है, crystal field splitting energy, it depends on the interaction of the magnitude of crystal field splitting energy or stabilizing energy depends on the interaction of metal and ligand. Okay, metal is assumed to be a point positive charge in crystal field theory. So larger the point positive charge, more intensely it will attract the ligands, because ligands are going to be assumed as anions or dipoles. If it is anionic, then it is point negative charge. If it is a neutral molecule, then it is going to act as an anion. It is going to act as a dipole, in which the negative part is going to get attracted towards the central metal atom, because it will be having higher oxidation. It will be having oxidation state +2, +3, and so on. So if the attraction between the metal and ligand is very high, the interaction will be high and the magnitude of CFSE will be very strong. Because if the ligand is getting pulled by the central metal atom, then it will, if it is pulled very intensely, then it will phase the d orbitals electron very intensely and there will be high repulsion. Similarly, there will be very low, there will be very lower in the, there will be reduction in the energies of the P2G level, increase in the energy of EG level, too much decrease in the levels of E2G. If the interaction is good, magnitude of CFSE will be high. Now, what are the factors that is going to determine the del O and del T magnitude? के लिए देखिए, दो ही चीज है आपके पास, लिगेंड्स हैं और मेटल है. So obviously it is going to be dependent on both of them, ligands and metals. First of all, we'll look at, by the way, आपके पास ना जो ligands वाला part है, that is more important for your syllabus rather than the central metal atom part. Fine. हमने बता दिया, but central metal atom is also important. It's not like it's है ही नहीं important. It is important. ठीक है. But the ligand one is very important. means the concept that you are going to learn about the ligands, if you hear these words and you are not able to say, oh yes, we learned this in we learned this in coordination compound, then you have not done coordination compound. So basically central metal atom के लिए क्या है? Central metal atom first of all series. Central metal atom के लिए A लिखना पड़ेगा. Series. What does it mean series? See, when you are in the 3D series, then the atomic number will be low. If the atomic number is low, that means the number of proton in the atom is low. If the number of proton is low, the nuclear charge, the positive charge on the nucleus will be low, and the ligands will not be getting attracted easily. When you are in the 3D series, when you go to the 4D series, just below, then obviously the atomic number increases, Z increases, and so on. So 3D will be having the smallest del O or del T, followed by 4D, and then the 5D will be having maximum. Similarly, it is also going to depend on the oxidation state, because higher the charge you are having in the central metal atom, higher will be the magnitude of CFSE. So zero charge will be having the least CFSE, followed by +1, followed by +2, followed by +3, followed by +4, +3, and followed by +4. Another thing that is going to determine the del O and del T is the ligand. Now, ligands based on the spectrochemical series. For this, we have a spectrochemical series. Spectrochemical series. According to this series, the ligands are divided into two different categories. One is known as the strong field ligand, the other is known as the weak field ligand. Strong field ligand, and the other one is known as the weak field ligand. So obviously, strong field ligands will give you a higher del O or del T compared to the weak field ligand. So these are the three factors which are going to determine the magnitude of del O and del T. And I will give you a complete picture. Okay, so when we have to take the pairing, when the delta O will be higher and when the pairing will be higher and so on. First of all, complete this down. Then we are going to look at the spectrochemical series. After we are done with the spectrochemical series, we are going to again look at the ligands of octahedral and then tetrahedral and so on. जल्दी जल्दी कीजिए, इसको खत्म करते हैं. CFP आपको खत्म हो जाएगा. Crystal field theory. Copy this down. Raise your hand once you are done. यहाँ तक everything makes sense? Yes or no? Mariam, Khadija, Siddiqa, Anna, Harsha, Yahya.
Yes, sir.
Yes, sir.
Yeah, ठीक है, very good. Please don't lose attention, है ना? The chain is quite long in this case. Waiting for Harsha and Yahya. Just waiting for Yahya now. Okay, Yahya is also done. Now, right next, spectrochemical series. Spectrochemical series. Now, if I talk about how this particular uh, like series is made, then this is going to be dependent on the kind of light which is absorbed by the particular metal and so on. Okay, experimental. This is completely experimental. When you are going to learn about the colors of different coordination compounds ना, उस टाइम फिर हम spectrochemical series कैसे आया है उसके बारे में बताएंगे. Right now, what is important is to learn the spectrochemical series. That is, iodide is in the last. Then you have the bromine negative. Then you have sulfur SCN negative. After that, you have chlorine negative. Then you have sulfur 2 negative. Then you have fluorine negative. Right? Now, these are known as, in general, in सबको एक साथ क्या बोला जाता है? Halogen doses. After this, you will have OH negative. Then this will be oxalate 2 negative, and then you will have the water. Right? So obviously, this is known as the oxygen donors. This is known as the oxygen donors. Then comes NCS negative. Please don't write now, okay? EDTA4 negative, NH3 ammonia. Then you have ethylene diamine. Then you have NO2 negative. All of these are known as nitrogen donors. After that, you have CN negative, and the maximum is from carbonyl CO. These are known as the carbon donors. है ना? क्या नाम है इनके वाले? Please let me write each and everything. Then you are going to write. Okay. These are known as the halogen donors, which are in the lower end of the, which are at the lower end of the spectrochemical series. The next we have is known as the oxygen donors. अच्छा, halogen donors को हम लोग X से रिप्रेजेंट कर सकते हैं, ऑक्सीजन डोनर्स को O से, and then we have the nitrogen donors. These are known as the nitrogen donors. And these two are known as the carbon donors. तो इसमें नाइट्रोजन डोनर्स को N से रिप्रेजेंट कर सकते हैं, एंड कार्बन डोनर्स को C से। तो एक तो आपके पास देखिए, एक सिंपल सा व्हाट यू कैन हैव लिस्ट इज दैट carbon donor is going to be the having highest, will be strong field ligand, strongest ligand, followed by nitrogen, followed by oxygen, and followed by halogen donors. ठीक है? C nox you can remember, after oxygen you are going to have halogen. ठीक है? एक तो ये C nox याद कर लीजिएगा आप लोग. Now how to remember this particular whole series? I know this in Hindi. I will say this in Hindi. ठीक है? ध्यान सुनिएगा. एक बार इस I के एक बार सचिन क्लास से फरार और ऑक्सलेट का पानी से प्यार. The here you have to write नाचते हुए. Let me write it. This is नाचते हुए उड़ता अमोनिया. यूडीटीए एजीटीए. उड़ता अमोनिया is ammonia in North Canada, in North Canada और कोलंबो में मिला. इन नॉर्थ कनाडा और कोलंबो में मिला. ठीक है? Now these are going to be quite important things. Fine. Nitrogen donors कौन है, carbon donors कौन है, all of these are going to help you in understanding strong field ligand and weak field ligand. Copy this down. Raise your hand once you're done. Waiting for Anna, Harsha, and Yahya. Waiting for Harsha and Yahya. Okay. Now, here what happens? We differentiate between the ligands of strong field and weak field. लिगेंड को कैसे डिस्ट्रीब्यूट किया हम लोगों ने? Ligands are distributed in two categories. Strong field ligands. Okay. So whenever you are going to have strong field ligand, in that case, del will be greater than pairing. Weak field ligands, del will be smaller than pairing. So obviously, in this case, what's going to happen? Pairing occurs. In this case, pairing does not occur. Okay. Now we are going to look at especially the when you are going to have six ligands, because देखिए स्ट्रॉन्ग फील्ड लिगेंड और वीक फील्ड लिगेंड हम लोगों ने कह दिया, लेकिन स्ट्रॉन्ग फील्ड लिगेंड ना ये डिपेंड करेगा कि सेंटर मेटल एटम कौन है, व्हाट इज द ऑक्सीडेशन स्टेट, और सारी चीजों पे डिपेंड करता है, राइट? तो लिखिएगा Ml6 metal with six ligands, that is the octahedral scale. In the case of octahedral splitting, right? यहाँ से देखिएगा, ठीक है, please see very carefully. First of all, you are going to look at the series. If it is of 3D series, if the metal is of 3D series and the oxidation state can be +2, +3 and +4. तो जब +2 में होगा, only carbon donors are strong field. Only carbon. In +3, carbon and nitrogen donors are strong field ligands. +4 में all are strong field ligands. Because in +4 it doesn't matter, मतलब ligand के ऊपर फर्क ही नहीं पड़ता. +4 is so such a high oxidation state that all the ligands they are going to become strong field ligands. The interaction with the metal atom is going to be so high. This is regarding 3D series. What about 4D and 5D series, sir? 4D and 5D series. In 4D and 5D series, all ligands are strong field. Are strong field ligands. The reason here is again the high nuclear charge, effective nuclear charge of the 4D and the 5D series. 5D में तो size ही बहुत कम रहता है. The charge is so high, right? Now in metal and ligand 6, there is only one thing that you have to remember very carefully. That is the case of cobalt 3 positive. If you have cobalt 3 positive, then in this case, carbon, nitrogen, and oxygen donors are strong field ligands. All this. Copy this down. Raise your hand once you. ठीक है, next देखिए. That is Ml4. Now in Ml4 there are two possibilities: tetrahedral and star signal. Okay, so whenever you have four ligands, then first of all you are going to look at the d electrons. If the d electron is between 0 to 7, okay, then in this case you're always going to have, we don't have to see anything else. This is always going to be tetrahedral, and the hybridization is going to be sp3. Same is the case if you're having D10 configuration. Even in D10 configuration, it's always going to be tetrahedral and sp3. The only case in which you have to see and analyze is the D8 and D9 case. Right? D8 and D9. D8 and D9, it will be tetrahedral if first it is 3D series, 3D series का होना चाहिए, and oxidation state should be +2. पहले तो ये देख लो. And furthermore, ligand should be before water, including water, ना. This bracket, ये math की language है. If I say 2 comma 4, that means between 2 and 4, excluding 2 and 4. If I say 2 comma 4 and I have bracket like this and like this, then it means including 2, excluding 4. If I have 2 comma 4 like this bracket, that means excluding 2, including 4. And if I have 2 comma 4 and the brackets are star bracket,